Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of identifying functions. This is standard A.12A in the great state of Texas, and we are using item number 4 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we are trying to find which graph represents y as a function of x. Okay, so we need to define that term. What does that mean to be a function? Well, an easy way to think of it is to use this simple definition. Each input leads to one and only one output. Now, we need to know this because it's not on our mathematics chart. It's not on our reference materials. But if you took 8th grade math last year, we also dealt with functions in 8th grade math. So it's the same idea as what you learned last year. So what does this mean with each input leading to one output? Well, when we're thinking inputs, hopefully we're thinking, is that like independent variables? And if you did think independent variable, you are correct. So these independent variables are the variables that we input into the equation. They're usually our starting point. 99 times out of 100, it's the x. Every once in a while, you're going to get a problem situation, and they want to replace it with an r or a t or something weird like that to fit the unique nature of that problem. But just think of them as your x values. So if our inputs are our independent variables, then our outputs, yes, you are correct, they are dependent variables. Now these can shift a little bit based on the problem situation. So in vanilla problems, they're just the y values. So basically each x leads to one y. But sometimes you'll get something that already declares itself a function, because they'll say, well, f of x, or g of x, or h of x. And that, first off, gives you a clue that it's a function. But secondly, that also is standing in for the dependent variable rather than the y. So that changes a little bit. So how can we tell if each x leads to one y? Well, it's easy because we got graphs. Sometimes we're just going to get a table, right? So let me plot some of these here. Okay, so let me just look for, I see a point right there, I see a point right there, I see a point right here. Okay, so let me just take these 3 points. I'm going to plot it for f, right? So I've got my x's and y's. I've got 2 and 7. I've got -8 and 0. And I've got 2 and -7. Now, it's not discrete, it is continuous, so there's a lot more points. But this is going to illustrate the purpose. Here's the problem. I've got 2 inputs right here. I've got a 2, but I've got that same input repeated down here as well. So basically, even though I'm listing 2 twice, it's one input. I've got one x value 2, and it leads to 2 different y values. So if I can have one input that leads to more than one output, then it is not a function. Now, when we've got these graphs, it's easy because we just draw vertical lines. There's actually something called the vertical line test. So take a look right here. If I were to choose that vertical line on the 2 value of x, I'm going to cross this function at least twice, which means it is not a function because I've got a 2 value that leads to 2 different y values. Now, sometimes you don't have a graph, so you have to look, does the x repeat? Okay, so if that's the case, look at g. I can draw all kinds of vertical lines because it's a parabola, but it's sideways, which means I can have one x value leading to more than one y value, so it's not a function. H, it's got all kinds of problems because take a look. I can draw this 5 right here, this vertical line. Now I'm hitting the graph 3 different times. So this is definitely not a function because you want each x value to only lead to one y value. Even though it is very squiggly, there's no way to draw a vertical line on J and have it hit the graph more than once, so that is my answer.